Hey, Raleigh Tinkers. I'm re-recording a director's cut of the presentation I had to give last week because there was an issue with the recording, so you guys get to see hopefully a better version. So the topic of the talk was about hyperfast inference systems and how that could change AI application design. So I was talking to someone at the first Raleigh Tinkerers meetup, and they had never heard of Cerebrus. And to me, or Cerebrus, however they pronounce it, to me, this is one of the more interesting areas of research going on in AI right now. How to make it faster. And what these folks at Cerebrus did was they have a complete custom hardware stack where they used a full silicon wafer to make a really fast inference chip, and you can kind of see how that's working here. Um, on this web page that they've got set up. So you can see I pasted in the prompt for creating an agenda for December 25th Tinkers, and it just basically blasted it out at 1700 tokens per second. So for comparison, your typical chat GPT system is going to be less than 100 tokens per second. Inference. So this is, almost 20 times faster. And a lot of times ChatGPT will, depending on load, go down to 20, 30 frames per second. So it gets really slow. And that's kind of the same for all of the major transformer-based network inference providers. Um, but Cerebrus isn't the only person doing this. We've also got Grok. They are very similar. They have their own hardware platform. I'm not sure the details of it. Obviously, it's very proprietary, but they can do something similar. They support other models, but they also have their own custom model that's a little bit faster. And you can see this is generating a huge amount of content much more quickly than you would typically get from ChatGPT or Gemini or any of the other guys, Claude, and they output it at 400 tokens per second here. And then there's also this other type of model from Mercury, and what this is a diffusion model, so it doesn't require any special hardware. It's a different algorithm from transformer attention networks. It'll run on CPU, it'll run on GPU, and it's still actively in development as a technology. Was a paper published a couple months ago that showed that they weren't um, Turing-complete diffusion models, but there's lots of people working on it. And if they do work out, you can kind of see that they're much faster than your typical provider, and they would be able to run on traditional hardware, traditional GPUs, NVIDIA stuff, your local computers, your cell phones. This is a very promising technology to bring really fast inference to those edge devices. Um, uh, yeah, what was I think I had one more thing to say about that. Yeah, but diffusion models, look them up. There was a new model just released a couple days ago, actually, since I did my presentation, based on Llama, where they potentially have solved the Turing complete problem of diffusion models. So what I've done using Cerebrus, and I'm using not using the Llama model, which is really fast, but I'm using the GLM model, which is an open source model that's focused on coding, and I've sort of made this tool that uses them as the back end, and it allows you to essentially make applications in real time, because once you have speed like that, you can get really fast application development and really at the click of a button. A couple of years ago, some of you might remember Jensen Wang of NVIDIA, just after Stable Diffusion was released, he said that one day every pixel will be created by artificial intelligence. So I think back then it was a little confusing. No one could really see what he meant. But I think once you think about how AI can be used to sort of create applications at the click of the button, you can kind of see how that would work. And then some folks at Anthropic, they recently kind of announced that they think software is solved. Essentially, people won't look at computers as things that run software, but instead they'll be tools that you use to get stuff done. So that's kind of what this prototype I've created here is showing. Excuse me. It shows a kind of a virtual desktop environment. So I've got kind of an app switcher simulator, and then these are different apps. And one of the apps, and these are all created through the system. One of the apps that I have here is an actual UMAP visualization of some files on my actual computer. So if you know what UMAP is, it's your semantic, or sorry, it's a dimensional reduction system. And so what I'm demonstrating here is we're using clip models for semantic semantic analysis of the images on my computer, and then the back end of this system um, outputs it as 3D data that we can then visualize in WebGL here. And so that's actually what you see here is actual files on my computer that the backend system, the AI has created a tool to download Hugging Face clip model, create the image embeddings, and then process them 3D, passes them to the UMAP algorithm, which turns your high dimensional latent vector into just 3 dimensions for visualization. And typically what this does is it shows clusters that are semantically similar. So you can see here I've got kind of 2 different clusters. That one seems to be related to symbols, and then other ones are symbols, and then we also have some semantic clustering of like images from Mars in here, and some different t-shirt kind of projects that I've made over the years. So I think we're at the point where you can essentially do real work with these AI generated applications. Another one that I have here, which is actually something I kind of made for my own uses, is a projector mapping tool. So essentially you define these perimeters for a polygon, and normally you would output this to a projector, like you're projecting onto a wall or a building face or something. You'll match these polygons to the physical geometry of your wall, and it'll then let you kind of warp the output to the geometry of the real world. So this lets me kind of create a polygon. I can define the edges, and then it'll project it onto the wall. And a kind of a neat thing about this application is I can also add videos to it, and it will allow the video to play in a loop with the projector mapping. So it's pretty cool. And I'll do a demo here. I don't know what I want to create. I guess something people seem to really like in the in-person AI Tinkers. Was someone made a wolf in 3D, and we'll see if we can do the same thing here. Voxel 3D wolf. So you see here the system kind of created a WebGL wolf, and you can kind of play around with it. The other thing that it will do is allow you to refine this. So let's just say I wanted to add for 3D printing. And you can see it added an export button here, but it kind of messed up the wolf. So that's a little bit related to the context length. Sometimes it might mess up the existing application code. But usually what you can do is just tell it to fix it, and it'll fix it. So it's a little bit of a work in progress. I'm pretty sure this type of error can be mitigated with some prompting adjustment. So one of the questions someone asked in the session was, how large can you make the applications? And it actually will get pretty large for your application size. And the reason being is that the system first creates tools, and then it creates the actual application. So in the case, for example, of the UMAP project, it created some tools. It created all of the tools first, and then once it creates the tools, instead of a huge long code file in the context, it's just a single simple description of the tool and how to call it in the response format, and then the front end application, the JavaScript and web code will use that to generate the application. So each tool can be the full context window of the model, and then that gets condensed down to an API call that then the front end can use to make very large applications. So once we've got some of the prompting dialed in, that should be a pretty reliable process. The other thing I had mentioned was we were still, Cerebrus, they're using a little bit of an older model. This is probably somewhere between a GPT-4 not in 5 class model, the GLM is. So it'll probably be a couple months until some of the better models for programming are hyperfast, and you could use them kind of in the loop for that. The other thing that this application is doing that's kind of unique is it has sort of a mono API. So all of these calls that use backend things go through a single API, and the side effect of that is that you can sort of make kind of fake API calls. Like this is not a file on my computer here for Raleigh travel. The API endpoint just saw that I was requesting an HTML page and just made one on the fly. So I could do something like, put another country in there, and I could put a fake theme descriptor. So none of this actually maps to any code. The AI just sees that I'm requesting a web page with a parameter theme for Terminator 2, and it just generates it on the fly like that. It can do the same thing with API calls, but we have that as part of the tool loop. So there's a video here of some of the other things that it can do and some information if you want to check that out. Let me see. Yeah, that's basically all the topics, but you can check it out here and send me a message on LinkedIn or wherever, and glad to chat with you more.